Alright, this is an overview of some of my radiation detectors and radioactive rocks. This is one of the first radiation detectors I got, and it looks like you can measure millirads per hour, and it seems to be a scintillation counter. So this doesn't quite look like a Geiger tube. And it looks like there seems to be a coating of material that what would happen is a radioactive particle would strike the tube, which has some material that is sensitive to radiation and would emit light, and then inside this tube is a photomultiplier that would take that minute amount of light created and amplify it to a reading that you could read on the dial here, and it has several knobs to adjust for background radiation and adjust the sensitivity. So I never got this working. It has an odd battery terminal, but kind of cool. And this was given to me by a friend who's a physicist, and it still works. It's one of the old civil defense Geiger counter units, and you can sometimes find these on eBay. Has a Geiger tube that you can hold in hand, and I think it also has this. The tube allows you to kind of open and close, so it will be. You can open it up, and it could detect more weaker forms of radiation, like beta radiation. And if you close it, you're canceling out all that betas, and you're just picking up the more intense gamma radiation that would be able to penetrate the steel of this casing. So we can give this guy a little test here. Here's my uranium ore, and I'm just going to I'll open up my little Geiger tube. So we're letting in the maximum amount of radiation, and we're counting. Don't get too close. We're counting back at this distance. We're counting around 200 counts per minute, or it's like 0.3 millirads per hour. So I'm kind of varying the distance with my hand a little bit here, but about 200 counts per minute, which is what we measured with our Arduino Geiger counter. And I'll close this up. Closing. Okay, and now we can still pick up some radiation, but a lot of it's blocked out because of our little shield. So our counts are lower, and the radiation we're detecting is a lower value. So meters like this are pretty cool. A nice relic from Cold War history. But it's not as nice as the Arduino radiation meter here, because this really has a nice advantage. It's not going to let you count the particles per minute. It also allows you to save them on the SD card. And it's really nice to have a graphical display that's displaying those counts. And you can really see how the counts vary with things like distance. And it's hard to just, wave around the meter and see how it dials in and out, but it's nice to get a nice visual graphic of how the counts come in over time. And it's easy to do little experiments like put some shielding in front of the counter and see how that affects the reading. So this is my uranium ore, and it's not dangerous. Actually, this is just a rock that would be similar to what you might find out in the desert somewhere. It's good to wear gloves so you don't accidentally get the dust on your fingers and then maybe ingest it or get it into a wound or something, and you have the radioactive dust somewhere on your person. So I'm just using gloves as a little just precautious, just to avoid any type of dust. But these rocks occur naturally in the environment, and you could order some off of a website called UnitedNuclear.com. So they've got lots of cool science toys and educational products for physics and nuclear energy. Another thing that's great that I got off of the United Nuclear website is they have some glass from the desert where the first the first atomic bomb was detonated. So from the Trinity test site, which is kind of cool. And you should still be able to pick up a little bit of radiation from it. So really nice piece of American history. That's pretty cool, and it comes with a little certificate from United Nuclear. It says, this isn't just a nuclear rock they found on the ground. It actually came from the test site, and they measured it for its radioactivity and for its authenticity. So that's kind of a nice piece of history to have. And this is my last bit. This is a little collection of nuclear rocks that my physics friend has given me. And so this was from a school. It had a nice little collection of radioactive minerals. And here's a description of each one, and it's labeled with each with a number that corresponds, and you can kind of look in the bin, and you can see that it's all labeled. So this is a 1, a pitch blend, and you can see the counts going up. Number 2, Carinite. And they vary in the amount of radiation they give off. But really interesting that you can find these rocks in nature, and they're giving off energy that has been stored in them for millions upon billions of years, and slowly releasing it from the point in time when they were created in a supernova so long ago. So really cool to do your own investigations into nuclear energy and have some pieces of natural history and American history. So